Good morning, viewers. This is yet another day. We are going to continue with what we have been doing. So, we have a question here, and the question reads, show that P, these are the coordinates of P, Q, 3, 4, 6, and R, 5, 6, 8 are collinear. So, we are supposed to show whether the 3 points are collinear or to show that the 3 points are collinear. So, showing the points are collinear, we need to understand the meaning of the term collinearity. And for us to understand the term collinear, we need to know that collinear points are those points that lie on a straight line. So for instance, if we have a Cartesian plane here, X and Y, we have 3 points which are lying on a straight line. 3 points lying on a straight line. We can therefore say the 3 points maybe P, Q, and R are collinear. Why? Because they are lying on a straight line. The 3 points are lying on a straight line. So for us to determine whether the 3 points are collinear, we need to find the position vectors of at least 2 vectors. So we can decide to find the position vector of PQ. So for us to find the position vector of PQ is equal to OQ minus OP. That is how we determine the position vector of PQ. And the position vector of PQ is going to be OQ is the coordinate of Q. So we can write this coordinate as a column vector, that is 3, 4, 6 minus P, 2, 3, and 5. So once we subtract, we are going to get PQ is 3 minus 2 is equal to 1. 4 minus 3 is equal to 1. 6 minus 5 is equal to 1. So that is the column vector of PQ. Therefore, we are going to continue with finding the second position vector. We can decide to find the position vector QR. So the position vector QR is going to be OR. O refers to the origin, that is 0, 0, minus OQ. So we start from the final vector minus the initial vector. Therefore, QR is going to be OR is 5, 6, 8. 5, 6, 8, written as a column vector, minus OQ. Q is 3, 4, 6, written as a column vector, 3, 4, 6. Once we subtract, we are going to get 5 minus 3 is 1, 2, 6 minus 4 is 2, and 8 minus 6 is 2. So we have the position vector of QR as 2, 2, 2. Having that, the next thing we are going to do is, we said we should show that PQ and R are collinear. Collinear points are always parallel, meaning a collinear point being parallel is a multiple of another. So we can therefore say PQ is equal to KQR. Why have we introduced constant K? Because parallel lines are multiples of another. So collinear points being also parallel, they are multiples of another. So we are going to take PQ, that is 1, 1, 1, is equal to K, QR is 2, 2, 2. Then we should determine the value of K. Upon determining the value of K, we should get a K, or we should get our K as constant. It should not change. If the values of K vary or change, that proves that the 3 points are not collinear. But if the value of K remains constant when we find the solution, that means that the 3 points are collinear. So the first one is going to be 1 is equal to K times 2 is equal to 2K, or 1 is equal to 2 times K is equal to 2K, or 1 is equal to 2 times K, 2K. Definitely, this proves that the value of K is the same, and our K is going to be a half. So having our K as a half, we can therefore say PQ vector is equivalent to a half QR. So this proves that the points, the two vectors are parallel to each other because they share a common point. They share a common point. The common point they are sharing, you see, is Q. So the common point they are sharing is Q, and they are parallel. PQ is parallel. Parallel, we can just use two lines. Is parallel to QR. Hence, P, Q, and R. We can complete that here. R collinear. So as simple as that, that is how we show whether points are collinear. Note this, don't forget this. This is very, very important. Collinear points are points that lie on a straight line. Collinear points are parallel to each other. And for us to determine whether vectors are parallel to each other, we understand the concept of parallelism from this formula here, meaning one vector is a multiple of another. That is why it was important for us to determine the value of k. Again, if it is your first time to view my content or to view my videos or to attend my online class, kindly click the button subscribe. It's a black button right there on your smartphone. Then turn on the notification bell so that each and every day I upload a new video, you always be updated. Thank you so much, and I believe and trust that as we continue, we are going to become better and better in mathematics. Thank you.